Hi, this is Koiro. This is a video that I have been, it's been lying on my disk a while, and I needed to, just finish up some stuff before I made this. Actually, the first part of this was made before I made the Christmas calendar series, and now I'm just finishing up the final touches, and I'm going to release this video now. And what we're going to make today is a simple joystick tester, and this is for the simple Commodore joystick. This is a quick shot from back in the day, and I also have a zipstick here that I want to test, and I have loads of other joysticks that need to be tested, and I could of course just connect the Commodore 64 to test this, but what's the reason not to make a joystick tester? And that is actually what we have done. So I'm just going to make this as simple as possible, and first we are going to start a bit so that you have an understanding of how the joystick port actually works. And remember, the joystick tester is not to be plugged into the Commodore 64. It's meant to be a standalone device, and that's why we have made it as we have. If I'm going to make this as it can plug in between the Commodore 64 and the joystick, I would have made a totally different design, and then I will have used logic gates to connect the inputs to the C64, but this is totally without logic gates. It's only the mechanical switches inside the joystick that's doing the job. And for those observant of you, my shirt here has the exact same colors as the backdrop on the presentation that I'm going to show you now. I just noticed. So let's get going. When I was a kid, I was really interested in what you could read on the back of this manual for the Commodore 64, where all the connections and stuff were listed. And the joystick ports was one of the first things that I learned to interface with, and it was really simple. And I was only 12 years old when I made my own joystick for this, or maybe I've just turned 13. I remember it was in the winter time, so I probably was 13. And I made this joystick out of wood and the copper foil and some solderings and some other stuff. And I thought it was a really good device. But let's start at the basics. What is this joystick port and how does it look? And this is an exact copy from the back of my, not my, but a C64 user manual. And you have 4 controls for directions. You have one for the potentiometer for the paddles. We are not going to cover these this time. And you have the one button on each joystick. And this also doubles up as light pen. We're probably going to show how this works too, but that will not be today. And you have the same for the joystick port B over here, the button, and you also, in addition to that, has 5 volt and you have ground. And you can see that there are maximum stated that you can draw 50 milliamps of this. And of course we are going to make this tester so that it doesn't draw anything of the port, because we are making this as a standalone device. The Joy 0 is up, Joy 1 is down, Joy 2 is left, and Joy 3 is right. And you can see the button here. So this is basically how this is done, and this is mapped how it should be inside your C64. And what's actually happening is that you are connecting each of these to a common point. And the common point for this is that you are connecting this to ground. Ground is pin 8. So this is basically how this is connected, and here it's illustrated with switches. And this is another point of illustrating this. This is meant to illustrate that if you want to move in this direction up like so, you connect both these switches at the same time. And if you go just this way, it's this switch, and of course this way here is these 2 switches. So it's just to show that how you are going diagonally on this simple kind of joystick, and of course the fire switch is up here. And what we are actually going to do when we are making this joystick tester is that we are making a simple resistor LED network that we are connecting with the switch that is inside the joystick. And we are using really old LEDs. I'm going to use some of my 90s and probably late 80s stock of LEDs, and they require quite the high current. And I say they have about 2 volt voltage drop, and I'm say it's going to go about 20 milliamps of power into this, and an easy calculation say that this is about 150 ohm resistors. And I have on here, this is the power LED, and of course you have the left, up, down and right, and you have the fire button over here. And I'm going to make them these colors when I start this construction. So this is really how simple this should be. And also, since we are connecting the 5 volt up here, if you have an auto fire circuit that requires some flip-flops or a timer or something inside the joystick, it will work as we are connecting the 5 volt. But in that case, there probably won't be a blinking like this. We have to see how this circuit actually works. But I didn't find any of my joysticks now with autofire, so I will probably test that. Maybe we have to do something with the fire detector circuit. But now let's just start to build this contraception. Yeah, let us just quickly draw up these schematics again, so that we know what we are dealing with and we get a quick repetition of this. And it's the power LED, and it's the 5 other LEDs, 4 for directions and 1 for the fire button. That's really all there is to it. And I also write out the pin numbers on all the connections that we need to connect to our joystick port. And here are most of the components we are going to use for this project. The biggest problem we have is that this Perfboard is not made specially for this 9-pin D-sub that has asymmetrical placed pins for the 4 and 5 pin row of pins. So you have to bend something to make it fit on the Perfboard, but we are going to try to do just that. And also this 9-pin connector that I've chosen has this, it expects to have these holes to connect to make the strain relief and also to make the positioning on the board easier. And that is about a 3.5 millimeter hole, I think, but I'm going to measure this out, of course. But that is also something we have to drill in this board before we fit this connector. And I'm carefully trying to bend the legs on the 4 pins part of the row with the 4 pins, and try to bend this in place so that we don't break anything. But this is kind of hard. Yeah, it's pins that's hardened, and it's not very easy to bend, but in the end we do manage to get this to fit in the board and make it kind of alright. And the 9-pin connector has not suffered any damage in this process. And then it is about making the user interface and make the 4 diodes that is making the directions fit into a square so that we know which way the joystick actually is pushed. And of course we have the power LED and we also have the fire button LED, but of course these could be placed anywhere, but it's very important to keep the square of the 4 diodes that's showing the directions. Yeah, that will be about so, I think. And then I also need to solder this down. And the soldering of the 9-pin D-sub is easy to get in place now when it's placed very well. And the stretch holes and everything is working real nice. So it's only to solder this in place. And when you are soldering LEDs and they are not in sockets, this is always a problem, because some LEDs do have these spacers on the pins and some don't, and they are not evenly placed. So I always end up soldering just one leg and go back and adjusting and solder the other. But the red and orange LED are quite easy. The green one, on the other hand, does not have this spacer on the pin, so here I'm just using a small piece of wood to keep the distance even. So I just put this in between the legs and I push this against the board, and also here I solder one side mostly, and I do have to do some adjusting afterwards. But without this piece of wood, it would almost impossible to place them evenly from the surface of the board. And as I said, there actually exist some spacers that you can put on a LED to keep it even from the surface of the PCB. And I've even seen people 3D print their own spacers and put in between to make this even. But for such a junkyard small project as this, the piece of wood will have to work as it might. Yeah, and fiddling about with these kind of things also make you repeat and practice on your local swear words. So it's not all bad either. It can come something good out of every situation. Yeah, and when everything looks straight enough, it's just to cut the legs off the success length of the excess length of your legs and just admire your work. And this is only the first half. The difficult part starts now, when you have to think about placing the wires and making the connections as efficient as possible. Yeah, I'm not going to even out this everything with color. I'm just going to use some excess leads that I have laying around and some spares. But all in all, I'm using thin wires so that it won't be very gunked up and it's easy to route them around. And I try to make them as short as possible. Yeah, I actually find using wire wrap leads to be the simplest, even though it's very thin. And that I also can just solder from the wire side. It's very easy. You just fill your hole with solder and you just put the end of the lead inside and make a joint. So it's very easy, and that won't bother the components on the component side. So that's a trick I'm using, and I'm also using it on this construction here. All in all, I'm just trying to be as efficient as possible, and I'm also using the resistors to make a connection, of course, where it's possible, and they are going kind of all over the place to make space for every resistor and to make the connection as efficient as possible. But by no means this is not a beauty contest, so I don't care if there is parallel lines on all my resistors. Yeah, so we're back at our joystick tester again, and I do think the only thing I got left is to solder in the plugs for supplying 5 volt, and I do have these contraptions, and I was thinking of joining them by wires, but maybe I should just fit them here on straight on the board. I have here routed the 5 volt like so, and I have the earth wire is this one over here, I think. So I could actually go about soldering something like this, and then I could solder something like this for this one. That could be an option. I'm not sure how that goes and how solid that will be. It probably won't be very solid, but then again, how much strain is this going to be? But I've had some problems with this earlier because this was very hot to get solder to stick to. But I will try to soften this up a bit. I think we use just wires. Now it should not be the surface, at least, that is making this not stick. Very good old file from back in the days. These should be well prepped now, and I just add some wires to this. I do always save on wire pieces like this, And I could of course go all the way and just, yeah, I can do that. No, we are just going to connect this with lab leads on the bench. I was thinking of making long cables so they will reach the power supply, but let's not go that way today. It will be much easier to store if I don't have a very long cable connected to this. And one end is marked, is this one. I take that as a positive wire. And one that is not marked is the negative wire. And the same this side here. Like so. Let's see if we can get them inside the holes of the board, or if we do have to extend the holes a bit. I do think it will be difficult to get this routed in like so. Yeah, maybe I should just go for a thinner wire. I think that would be a better solution. Yeah, so I'm going to just stick with this one. This is a bit sketchy China thing, but I have used some of this before. It's very rubbery, this wire. They say that it should be silicone tops on this, but that I'm not sure of. This is actually not normal copper cable. It's at least color like iron or steel, but it might be that it's tinned, but probably not for this price. That was the red one, and the black one. One wire, one cord or braid of this did escape, not anymore. Brand new side cutter. Yeah, I use my brand new side cutters instead. These pieces of shrink tube, it's just to keep the wires together. And of course I also need one that is slightly bigger, that I can stretch over this one. It will at least have to be that size. Yeah, maybe that will be okay. I have two pieces of this. I will be preparing this for soldering now, with dismantling some of the cable and just twisting it. And yeah, making it so that it will fit the points of the banana 4mm sockets. That wire actually soldered quite good. And then it was these ones. Let's see if they works better now that I have used the file on them on this side. Yeah, that actually stuck very well. That is going to be a good joint for that one. And actually I do wonder if this one will keep like so. Take a piece of that. Like so. I didn't have any more of these black ones, so in my world then yellow is ground and the blue or red is of course plus. The problems I had with these before is that they actually, when I used heat, they melt inside here, so this is not very good reliable contacts. But let's see what we can do here now. This is of course not going to be a very professional looking anything. But it's good to not have things short out when you are using power supplies on your bench. So that's why I was thinking that this probably would be okay. Like so. And this one, yeah, something like so. And then quick blow with the rework station. This will not shrink as much as we want anyway. This will be good enough for this. And then I'm just going to take these and space them up like so. Yes, are we going to try? We could. I do have 5 volt here, I think. And this is not working. I wonder if I have turned this around. And of course I have. Then I need to change them over here. I can of course check that the rest is working first. I do have some old joysticks. I don't know if they work or not, and that is probably why I need a tester. An old Zipstick clone or something. Oh, it's the original Zipstick. Oh, this plug is a really tight fit in this D-sub. Yeah, and you can see that it's actually working. I don't know if you see this very well on film, but like so. And the power button like so. And the corners like so. Yeah, so our only fix is that we need to change these around. Or I'm going to get some red and black shrink tube on this. That would be even better. Yeah, let's try that. Here I have some larger size heat shrink. So, it was this one. This is sketchy stuff. Yeah, we do have to call this a success, don't we? So then the red one should be like so, and the black one should be like so, even though the wire want this otherwise. And I also have another joystick here. This is an old quick shot, Spectra video or quick shots or whatever they was called. And let's see how this goes. Yeah, it also works. Might be a bit of sketchy. And this also it has auto fire. Some of these does. Because when I was seeing this it was kind of blinking, but that might just be bad contact. This might be in a bit of need for a cleaning. Yeah, but both the joystick tester and the joystick works just fine. So this was a very simple construction made by a simple guy, but this would work. I could of course make this every other way with, you can use some logic, I can even test states and so on, but I can also make an instrument that measures the resistance here, but why bother? I think this is quite okay for what it's meant to do. Yes, this was a not so short video about a really simple build, but it's something I do need it from time to time, and it's kind of fun to make. It's really simple, so it's not very, it's not very demanding. It's very simple. It's just the mechanics of doing and creating some really simple stuff. So I kind of like to do this off-side project from time to time. Hope you enjoyed the video. Hope you watch some of my videos till the end. I do need the seer time. I need the air time so that I will be able to get my YouTube membership. I have now been waiting for 3 years, but they have stretched the goal somewhat. But now they have lowered it again. So I'm only in demand for about 500 hours of viewing time, and hopefully I will get that now in the next couple of months. So thanks for watching, hope to see you in my next one.